Hello there. Have you ever been part of the discussion whether Java is pass by value or pass by reference? If yes, there are a lot of beginners on Java who also get confused by this. So today we will do a small exercise. We will see how stack works, how different objects allocation, primitives, etc. works, what is a stack, what is action frame. We will not go much in depth, but we will go sufficient enough in depth so that you can understand and visualize what's going on, and which will help you figure out what is the right answer of this question whether Java is passed by value or passed by reference. Right? So let's begin. This is a memory visualizer demo class. I have prepared it just to demonstrate how stack works, how object allocation happens, how references work, and how things work for primitives. So for demo, we need to start this class in debug mode. This is the debug pointer, class is in debug mode. And here, if you see, the stack starts here. So this is the first action frame. This action frame contains args, right? This args is this, right? It's empty. We can see there is one more plugin which I use for easy visualization, and its name is Java Visualizer. So I think we should use this first and then come back to the stack. So here you can see this is the call stack, and in this call stack, this is the first action frame in objects area. There is nothing right now. Let's move the control to the next line, and if you see server ID equals to 101, right? So in this action space, there is one variable defined server ID, and which is holding a value of 101. This is primitive server ID. Now here user A equals to new user, which means it will try to create a new user object with these values and assign the reference of this object to user A. Let's go inside user object constructor and see what happens. Okay, so we are at line 51, and see, since this is the constructor, it is initializing the object, so you can identify it with init. This is the another action space on the stack. First this and then this one. This action space knows what is the previous action space, right? And here in this you see ID and name. ID equals to 1, Arjun is the name, right? So this ID is this one and this name is this one. Okay, so what does this action space do? It holds the values which are received from the calling method, and then it is holding a reference this, and it is trying to create an object here. Okay, so if you see friend ID name, friend ID name, these are the things here. So as soon as the control is here, it will try to create an object of this user, and this guy here is holding a value or holding a reference which is pointing to this object. If I move ahead, you can see the name is assigned to Arjun. So this dot name equals to name, and this name is Arjun, right? Same way, ID will be allocated to 1, right? So as soon as that constructor is called, control is back, that object is created, but that reference this is still there, and that reference will be allocated to user A. Let's see. So here you can see user A is pointing to the user object which was created by the user constructor. Same way, if we go inside this, so init will be called, right? Init will be called. So again, there is something which is added on the stack. This is space, this action area, and in this action area here, ID and name are the values of this ID and this ID, right? And now these values will be allocated to this, and when we assign to these, it's like this dot id, this dot name, which means this dot id, this dot name. So the values which are received here are these values 2 and Vikram. They will be allocated to 2 to id here, name, Vikram, right? So let's go ahead and see. So as soon as we will go back from here, this space, this action space will go away from this stack. We will go back onto the main stack inside the main method, right? And the reference is still to be assigned. So when we move ahead, right? So this action is assigned to user B. This reference is assigned to user B. So user B holds the location or the reference which helps it figure out where is the object. So objects are created here and the reference variables are here, and these reference variables holds the reference location. In case of primitives, primitives are not created on object on heap in the object area. So this value 101 is hold in the stack itself, right? Now if we see this line, user array equals to user A, user B, right? So these are the two objects or two reference which are already pointing to objects which are created. So basically it will create an array, right? Since it's not in primitive, it will be created in the object area, and these two, user A and user V, will be allocated to this array. What does it mean? Does it mean the objects, these two objects will be recreated? No. Array will hold the reference to these objects. Let's see, right? So this is the user array created, and since there were two values 0 and 1, 0 and 1, 0 is pointing to user A and 1 is pointing to user B, and this is the user array reference which holds the value or the reference value which can helps it point to this user array which is created on the object area or heap, you can call it. If I move to the next line, or if when this line is executed, this user A, Arjun, will be added to the list, right? This set followers. So first I cross this line, and if I see followers, a hash set is created. Right now there is nothing inside it. As soon as I execute this line, so user A, Arjun, right? User A is the one with the Arjun, right? So here if you see, it have only one element, so that's why 0, and it is pointing to Arjun, right? So that's how objects are not created again and again. And when the referencing happens, what is happening basically? The reference value, which is held by the reference variable, is copied and passed, or here in this case, not even copied and passed. In this case, it is still used, the same values are used because they are in the same action area, right? But when a method is called, the copy of these values will be passed, right? What does it mean when we say the copy of the values will be passed? So we will see. But as soon as this method is called, so this is another action space added to the stack. So this is a stack. This is one action area which belongs to method main. As soon as we call process network, so there another will be added for the process network. Let's execute it. Okay, we executed it, but it's not in debug. Let's go back. Okay. So this is the one. As soon as process network method is called, right now this line is not executed, right? So you can see this have four arguments: ID, user U, array, and set. We can see all these four here: ID, U, array, set. Okay. So basically what has happened for ID, it is holding the value 101, which is the server ID 101 here. So in this case, this 101 is copied and assigned to ID. So this 101 is actually replicated and assigned to this. In case of user, right, when user A is passed, so user A here in this block holds something, a reference variable, right, address to this object. This address is copied and assigned to this. Since this guy also have the same address or same reference value, it is able to figure out where the original object is or where the object is. So that's why here also what happened, whatever was contained inside this was copied and assigned to this. So from user A to U, it has copied the reference value. In case of primitive, it has copied the actual value, right? So basically, in case of primitives, the value itself is the real value of that variable. In case of these object references, the value is not the real value of the object, but the reference location, right? So basically what happens, whatever is the value which is held by user A, user B or server ID, only that is passed. Only difference is in case of objects, user A, the value which is copied and passed to you, it means that it is a address, or address is not the exact right word, but it is a way to figure out where the actual object is, right? So that's why we say that in Java, generally we pass the value, but value means different when it is primitive and it means something else when it is the object, right? So I'll come back to here, and if I show you, ID is 101, right? This ID is 101, but this line is about to do an assignment of 999 to ID. So when this assignment will happen, if this and this are not two different values, both should change, right? But if these two are different copies, then only this should change. Let's see what happens. Okay, so only this has changed. So basically, in case of primitives, when you pass the copy. So this guy is holding the copy. And if you do anything with this, it will impact or it will have the scope of this method only, right? So this is the action space in which these values are being held. Now, if I go to this line, and if here I say user.name equals to Arjun verified. So basically it is trying to access the name, and this is trying to access the name with the help of reference value. But since this reference value and this reference value, user A, is same, right? Both of this value is exactly same as this, and it is trying to point to the same user, right? So if I do some operation on the object which is being referenced by u, will also reflect the change for user A, right? So if I do this u dot name Arjun verified, so basically this will change this Arjun verified, and since this is pointing to user A, so user A will also be able to see the difference. Let's execute this. Okay, here, yes. So user ID, and it is changed to Arjun verified, and this is also able to see the Arjun verified, right? Now there is another object created, user C. So user C will be created inside this action space, right? It is on a stack. This was on a stack, and then this is added on a stack. But this is the, you can see it like a method level scope. So user C, since it is being created inside user C, so when we call this, a new user object will be created, which will have Sita and 3, and it will be referenced using this variable. So here we should see user C. See, so user C is created and it is referencing to this, right? Now this guy here, array 1, array 1. So the array is pointing to this array and it is trying to access array 1, which means this, and it is assigning this. This is assigned right now to this object, the one which contains Vikram. But now this is assigning it to the user C. So basically it is trying to assign this the reference value which points to user C, right? So this user C, basically it is copying the address from here or the reference value from here to here, and the moment it is copied here, it will start pointing to this automatically. Let's see. Okay, so now see, this is pointing to here, and here you see there is a set which is coming from here. So this is the set, right? And now it is trying to add user C. So user C is basically this object and set is this. So when you execute set.add C, so you are trying to set.add in this, what you are trying to add? The reference of C. So you will copy the reference of this and add to this, which means it will create one here and that will point to this, right? So let's see. Okay, so as soon as we have done, it has reorganized it. So now when you do set.add C, so here one more is added and this one more is pointing to, okay, so this set is having 0, which was pointing to Arjun already. Now it is pointing to Sita also, right? Now, so far it's clear, I guess. If no, please feel free to ask the questions. Now we will go inside deep dive method. So what will happen? Now process network method is trying to go inside another method, deep dive. So basically on this stack, one more action space will be added. Let's go. Okay, so yes, see, deep dive, another space is added. So this method, when it was called, it is holding the values received in primary and secondary. Primary is basically user U, right, which is Arjun verified. So here if you see, primary is pointing to Arjun verified, and secondary was user C, right? So secondary is pointing to Sita. So far it looks like fine. So what happened basically, the reference value which was held by this, the value inside this is basically copied and pasted inside is this, and Java is able to figure out that this value means reference of this object, right? Now there is this line, primary dot friend equals to secondary. So primary is this object and inside friend there is nothing, right? So what it will do, this secondary guy, this is pointing to Sita. So now it is trying to assign to this friend the value of this. So when it says secondary, so it will pick up this value, okay, this was value, and it will point this to this value. So what will happen? User friend will start pointing to Sita, this object. Let's see. Okay, so it has reshuffled, and what has happened? Yeah. So now the friend is not null for Arjun verified. It is pointing to Sita. Now primary is pointing to this user. And what we are doing, we are trying to create a new user with ghost 404. So a new object will be created and the reference to that object will be held by this variable, which means this guy will start pointing to new user. Let's see. Okay. So now primary is pointing to this, right? Now secondary is pointing to Sita and we are trying to set it null. So what will happen? If we set it to null, does it mean it will release the object and memory will be free? What will happen? So when we do secondary equals to null, it's like we are trying to save null here, which means secondary will hold null and it means it is not pointing to any object. So this connection red one, this will be gone. But this user object, this is being referenced from this hash map, from this array, from this array. So this object will not garbage collected, even if we are doing secondary equals to null. So that's why a lot of time if we release the references forcefully, it doesn't mean that it will be garbage collected because that object is referenced by many other places possibly, right? So if I move forward here and if I come back to the process network method, now what will happen? Deep dive stack is gone, deep dive action space is gone. Now the call will go from here to here. So process network stack will also be gone, right? So now the stack is here. So basically if you see during all this method chaining, we end up modifying from Arjun verified, from Arjun to Arjun verified. And we end up having one more object, which is Sita. And this is being held by user array, right? This array. And this is being held by another hash set, which is the followers, right? And we feel that we called another methods, we created the variables, we did something, and we now the method call is over, but still where is memory is somewhere, right? So until and unless this method call is over, these objects will not be released. But in this process, we have understood that, okay, whenever a method call happens, another action space is added and there are a lot of local reference variables, data, and everything is hold in that space for that method. And as soon as that method call returns, that is gone from the stack, right? So in the end, this is on the stack. If I want to show you the stack in this form also, if it helps you. As soon as I start this class again in debug mode, and the debug pointer is at line number 8 and the control is at number 8 right now. So main method and 8 is the line number. So this is the first thing on the stack, and on the stack this is the action space for this stack. Right now it have args which is received when the method is called, and if I move further, so in this action space server id 101 is created, and when I move further and if I go inside this, basically init will be called. So this is a constructor and this will be called for the object initialization. So if I go inside, you see on a stack init is added, right? And this id which is 1, this is here, and this name which is called the name was sent to this method, so this is hold here, right? So from where, so Arjun was passed as a string here, and here this name is holding this, right? And if I go to next, this will assign the name here, id will be also assigned. So right now this dot id is 0. If I call this id is 1, name is assigned. What happens if I move ahead? So now this is the object basically which is supposed to be returned back, or the reference to the object. So it's the 756 is the, you can say, reference value. Okay, so this value will be assigned. You can imagine this as the value which will be allocated to user A here. So user A, if you go here, so yes, user A is pointing to this, right? So when we say object reference, it points to something, right? When we want to see the block basically, right? So this, what is this? This is basically this string, memory visualizer demo $user at the rate 756. So it's the simplified version, but you can imagine this is stored inside this, and this stored value points to the object, right? So if you go further, you will see another object allocation, and if you go furthermore inside this, then you can see another thing is added on the stack, right? And if you move further inside deep dive, you will see one more thing is added on the stack, right? And if let's go till here, and if I go here, user A was Arjun verified. You can see on this stack it is reflected as Arjun verified now. Address is 756, and if I go here and if we are able to find Arjun verified here, it is still 756, and if you go here, uh, it's not here. Okay, so but wherever 756 is, it is Arjun verified. It's the same object. But if you see id equals to 999, here it is not this, strange string allocated to id. It is actually the 999, and if you see id here, it is server id 101. So it is the actual value, not the address of something, right? So that's why what happens when a method is called, and basically what happens if primitive is passed, this will be passed. If the variable is holding the reference to an object, this will be passed. So whatever the value that variable is holding is passed, right? In this case 101 remains 101, but in this case this will result into a address to a another object, right? So Java, I hope you understand by now that why we call it pass by value. It's just that value means something else when objects are in picture. In primitive case, value means the actual value. And during this process, I think you have got a bit of idea that how to see the stack, how to see the action spaces on a stack, and how to able to figure out which object is referenced where, and some idea about the Java Visualizer plugin. So keep learning. If you have some questions, please post them in the comment section. Have a good time.